is a movie.
Okay, so do we actually know The Matrix, the movie?
Yeah, I hope so. Yeah.
Okay. Okay, that's good. I don't think I ever made it through the movie without falling asleep. But it's a movie that came out when I was in high school.
It was so good.
That's how old it is.
You seem like all you have a stress since you probably slept with
Does anybody know what a matrix is? Not the movie. Has anyone heard of a matrix?
Oh, they're using. I've heard of it. Government.
Democratic matrix.
It's compare things.
Mathematics. Mathematics.
Compare numbers.
Okay, well, it deals with numbers.
Yes, it does.
Okay, a matrix is a rectangular array of numbers. It looks something like this. Okay, so we have these numbers organized rectangularly, kind of like a table, but without the other lines. Okay. Oh, wait. And then we have these brackets on the outside. So we have rows and columns. Okay. An entry is any number in the matrix. Okay. And we say that the order of a matrix is the number of rows by the number of columns. Not time. By. Like when you talk about a piece of lumber, a 2x4. Okay, what is a 2x4? 2 inches by 4 inches? Okay. So this is a 3 by 2 because there's 3 rows and 2 columns. 1, 2, 3 rows, 1, 2 columns. Okay. Order becomes very important when we do operations with matrices on Friday. Okay? One matrix, multiple matrices. Okay? Plural is matrix, or singular is matrix, plural matrices. Okay? A square matrix. Exactly what it sounds like. Same number of rows as columns. It makes square matrices are special. We'll talk about why they're special later. The reason we are talking about matrices after our systems chapter is we can actually use matrices to help us solve systems of equations. Okay. Everyone good here with the lingo? Okay. All right. So an augmented matrix is something that we form using a system of linear equations. Okay? If we have a system of linear equations, we're going to take it and form an augmented matrix, and it's something that we can mess around with until we get a certain form to find out our answer. So go ahead and write down this system, and we'll talk about what the augmented matrix would be. Okay, so I'm going to flip back very quickly. If we go back to this matrix right here, you notice that it's just numbers, correct? Okay, an augmented matrix is going to have something special. Since we're talking about a system of equations, we have these equal signs. So our augmented matrix is going to look like this. All right, an augmented matrix, it has just numbers. There are no variables. We just look at the coefficients. So 1x minus 4y plus 3z equals 5. So there's our first row, where this colon kind of takes place of our equal sign, and we are just talking about the coefficients. Okay, so our second row, we're going to take our second equation, coefficients, -1, 3, -1, and then -3. What would our last column be? I mean, our last row be?
-4.
2, 0, -4, colon 6. Okay, this is our augmented matrix that represents our system of equations. Okay, we're just getting the basics down today, and then we'll figure out how to work with this to solve it tomorrow. Okay, questions about this augmented matrix? We're using all these cool words, right? Okay. Now, we are going to talk about elementary row operations. Because what we're going to do is we're going to take this augmented matrix, and tomorrow we are going to perform row operations to help us solve our system of equations. So you need to know what's legal to do with a matrix. Okay? So what we can do is we can take two rows and we can interchange them. What does interchange mean? Switch. Okay? So we're going to start out with this matrix. Okay? It is legal for me to say I want to switch row 1 with row 3. And my new matrix would be 1, -2, 3, -1, 3, 0, 2, -5, 5. I can take two rows and we can change places. Okay.
Like I'm just I like this chase. Because like if you're doing something where you add
Okay, I will tell you in a little bit why we remember these other pictures. Okay? But we need to know what's legal first. Okay? Okay, so we can interchange two rows. We can also multiply a row by a non-zero constant. So let's take our original matrix again. And it is legal for us to take row 3, for example, and multiply it by -2. Which means row 1 and 2 would stay the same. And my third row would now be -2, 4, -6. So it is legal to multiply by a non-zero constant, not multiply by 0. The last operation that is legal is adding a multiple of a row to another row. Okay. So let's start out with our original matrix again. It is okay for me to say, all right, I'm going to take row 2 and multiply it by 2 and add it to row 1. Okay? And we can decide, we can replace it with row 1 or row 2. I'm going to replace it in row 1. So I'm going to take row 2, multiply it by 2, add it to row 1, and that's going to be my new row 1. So when I multiply this second row by 2 and add it to 1, what do I get here? 0. 3 times 2 plus -5. 0 times 2 plus 5. And then everything else can stay the same. Okay. So we can take a row and we can multiply it by something and add it to another row. You can multiply by 1 and add them together. Okay, that doesn't matter. Okay. Row equivalent means if one matrix can be obtained from the other by a sequence of elementary row operations. Okay, so these are row equivalent, they just look different. Okay. Okay, I will relate this back to an augmented matrix very soon. So we're going to go through a couple of examples where we need to identify the row operations that's taking place. Okay. So from this matrix to this matrix, we need to figure out what the row operation is and what this question mark should be.
Multiply by 1/3.
Okay, not everybody all at once. Okay. What's divided by 3? Okay, we're taking row 1 and we're multiplying by 1/3, right? Oh, row 1. Which means our question mark would be what? Row 2 stays the same?
Yeah.
Well, doesn't stay the same. What?
Oh, multiply by -3 and add to the bottom.
multiply by -3 and add to the bottom. 3 times -3 is -9. I don't think that's going to get me far.
It's close.
Yeah, I didn't see that.
It's something with three. Three. It's just regular.
So if row 1 is multiplied by 3 and then added to row 2, that's what you're telling me?
Yeah. Yeah.
3 times 3 plus -4. -1 times 3 plus 3.
Yeah.
-4 times 3 plus 7.
Rachel.
So yes, that's what's happening. Okay, you need to be able to identify what's going on. Some's going to be more obvious than others. Okay, so why are we doing this? Always the question. Okay, first of all, when we talk about an augmented matrix, we have something that is called row echelon form and reduced row echelon form. Okay? Row echelon form means any row of all zeros goes to the bottom, if there is that. All other rows have the first non-zero entry as 1. And for 2 successive non-zero rows, the leading one is in the higher row is farther to the left than the lower row. Blah. What does that mean?
I don't know.
This is what it means. You have a diagonal of 1s with zeros in front. This is row echelon form. We have this diagonal of 1s that start in the left corner. And to the left of that diagonal of 1s, we have zeros. If we have an all-zero row, it will go here, in the very bottom. This is row echelon form.
So what if like the first what if like the first number is not 1? I can't call that.
Then you would divide it by something, or you'd multiply by a fraction to make it. Okay? Why would this be helpful?
Like simplifying.
Let's go down to here. What does this bottom row mean?
That.
Z equals -2.
Yep.
Oh. What does this mean? Y minus Z equals 2.
Ooh.
Oh, we know Z from here.
Yeah, we do.
Okay. X minus Y plus 2Z equals 4.
Wait, so can you get to there?
By elementary row operations, you sure can. That's what we'll do tomorrow.
Oh.
Sounds fun.
Two successful rows.
We also have something called reduced row echelon form, where zeros are above and below every leading one, which means we have our seat belt of 1s and the rest are zeros. Because what is this?
That means they all equal that.
This means what?
Equals 2.
X equals 2.
X
Y equals 3.
equals
Z equals 4. Do we know the solution to this system? Straightforward. Okay. So if we can use our elementary row operations to get to row echelon form and or reduced row echelon form, we can solve our system. Okay. So what is X for this system? What is Y? What is Z?
4.
Okay. One last example, and then I'll get you to your homework and teacher recommendation. Please write this augmented matrix down. What form is this in, Aaron?
Row name. Echelon.
Row echelon
Right.
form.
Give me more space, please.
What?
I need more space.
You can. Are you at the end of your piece of paper? This first row, we can interpret as what equation?
4.
Second line. And last. All right. So our solution to this system of equations, we know z is -2. Y minus z should equal 2. What is y? 0. Then we can move up. What? Y minus z equals 2. This is y plus 2. All right, now that we have y and z, x minus y plus 2z equals 4. What does that make s?
8.
This is a -4 actually. All right. Tomorrow we're gonna work on getting it into this form so we can solve. Okay, right now in your homework it's going to be given to you in echelon, row echelon, or reduced row echelon form. In your homework you will also have to identify row operations. Okay, so that'll be 2 different. Okay, here's your homework. You need graphing calculators tomorrow. Bring them.